Okay, question 12 from the Unit 10 review is kind of a short one. It's asking, we have 17 possible books, and we want to make a collection of 7 books. In a collection, I'm just selecting books, but the order in which I select them doesn't matter. I don't have a collection that's ranked from highest preferred to lowest preferred, or personally, I don't. So in this question, I don't believe we're looking for order that matters, just the selection itself that matters. So in this case, we're going to be using a combination. We want to choose a combination of 17 possible books. We only want to take 7 of them. So in order to solve this, all I have to do is 17 C7 in my calculator. And once I've done that, I'm going to end up with 19,448 possible combinations for my collection. We're going to look at question 13 now. For question 13, we are volunteering to help to drive children at a charity event to the zoo, but we can only fit 6 of the 20 children into our van. So we want to do groups of 6 children. So we want to choose 6 of the 20. So in this case, again, order doesn't matter. We are not picking our favorites. So like, child's number 1 can sit in this certain seat and child number 2 can sit in that one. It doesn't work like that. Instead, we're just choosing groups. So since order doesn't matter, we're going to be using a combination. We have 20 total children, and we're only selecting 6 of them to ride at a time. So in this case, if I do 20 and I choose 6 in my calculator, 20C6, we're going to end up at 38,760 total combinations of children that we can select to take to the zoo. For question 14, we have a health inspector that has to visit 4 out of 8 restaurants on Monday, and she has to pick a first, second, third, and fourth restaurant. In this case, the order does matter, probably because she has to choose how she's going to drive between all of them, and she probably wants to save herself some time and distance. So because the order matters, we're going to be using a permutation. And in order to do this permutation, we're going to start with the total number of restaurants, and we're going to permutate the 4 she wants to actually visit, and it's going to arrange them. So we're going to do 8P4 in our calculators here, and we're going to get 1,680 different ways that she can choose to arrange 4 out of these 8 restaurants. Let's go ahead and take a look at question 15. In order to win in a lottery, we have to correctly select 7 numbers from a total collection of 47 numbers, 1 through 47. We're trying to figure out how many different selections are possible if the order that the numbers are picked doesn't matter. So as long as you match the numbers, it doesn't matter when you pick them, as long as they're all there. So in this case, since the order does not matter, we're going to be using a combination. And we have 47 total numbers to choose from, and we only have to pick 7 of them. So let's see how likely it is that we're going to win that lottery. So 47 total numbers, and we are going to choose 7. We'll type that in the calculator. And wow, it doesn't look like we're going to win. Our total number of options here is 62,891,499 ways that we can choose these numbers. So our chances to win are probably 1 in 62,891,499. Not very likely. Let's go ahead and push through and work on the last question here. For this question, we have a choir. We have 5 tenors, 2 tenors, 5 altos, and 3 sopranos that are going to be chosen from a group of 5 tenors, 7 altos, and 5 sopranos. So we have to figure out the number of ways that we can choose people. And in this case, each specific classification of singer is its own category. So we're going to be choosing from within those, not singers altogether. So in this case, we have to choose 2 tenors out of the 5 tenors that we have. I'm assuming that the order doesn't matter. It doesn't say that it does, and I can't imagine that it would. So we're going to be choosing 2 out of the 5 tenors. So we're going to use a combination, and we're going to have 5 to start with, and we're choosing 2 of them. Now that's just for the tenors. For the altos, we have 7 total, and we're choosing 5. So 7, choose 5. And then for the sopranos over here, we have 5 altogether, and we have to choose 3 of them. Now, each of these selections is happening simultaneously. They all have to be chosen at the same time. So we're going to choose these tenors, tenors, altos, and sopranos at the same time, which means we're going to use a fundamental counting principle. We're going to multiply all of our possible options together to find our total answer. So we just need to type 5C2 times 7C5 times 5C3 into our calculator to find the final answer. So I'm going to go ahead and do that here. We have 5C2 times 7 C5 times 5 C3, and my final answer is 2,100 different ways to select these number of singers from these number of people altogether. Oh, and it says right there, the order that they're picked doesn't matter. So, perfect. Oh, that's a different question. Haha, just kidding. But we did it. This is the answer. And we'll pick up with number 17 in the next video.